Hello all. We'll continue our tutorial on creating the Python script for our file, which is shown in this article. So you must be familiar if you're following the series. So I'll just continue to the third part, where earlier what we have done is that our tutorial ended at defining the elastic properties. So I have changed this code a bit. I'm going to explain what I did here. You can basically see that this materials which I have defined are the five materials: BLT, ballast, SBT, subballast, SBG, subgrade, then sleeper and rail. So the similar order will be followed for their row, which is the density: 2400, 2400, 2000, 2400 and 7850, because rail is made up of steel, so the row will be higher. Then the elastic modulus, E mod, again the same order will be followed how the materials are defined, and then mu, which is the Poisson's ratio, and we assign this Poisson's ratio using a loop. You can do that individually, but I prefer not writing all this line, and I can just write a loop. So here you can see this line MDB model 1 will be same, because we are doing all this in the model 1. You can also change your model name later on, but we are not going to do that in this in this tutorial. Now material mats I, basically I is following the range length of mats. Basically this matrix has a length of 5 because it has 5 elements: 1 2 3 4 and 5. So the range 5 will basically be 0 1 2 3 and 4. So the I value will vary from 0 1 2 3 and 4, and at last the 4 the loop will cease to exist, or it will exit the loop. Now material name will be assigned from here. Then in the material mat I, the density will be assigned to row I. The I will be the element respective whatever the value of I will be. If it's 0, then the first material will be assigned this 0 value. So in Python the count start from 0, so 0 1 2, so like that. If you are familiar with MATLAB, their count starts with 1. And similarly we have this elastic Young's modulus and mu assigned here like that, although alpha and beta are constant, which we have talked previously, will not be assigned differently. Now the other part, I have done a little bit of tweaking here, because we have more column materials. So if you can see here, these three materials, ballast, subballast and subgrade, are having a C and phi more column plasticity assigned to them. So what we do is that we have to assign this more column plasticity. Again very similar, we have to very similar density, elastic properties and damping. We have more column plasticity, and in the more column plasticity we have our friction angle, which is phi. Again I have created a table of phi, and I have again created a mats underscore mc. So these matrix will only contain the more column material, name of those more column material, because sleeper and rail we are considering as elastic. Now you can check why we have considered sleeper and rail as elastic and not all of them as elastic. Basically because these are granular materials, so we have to consider the plasticity, while sleeper and rail are pretty much solid and continuous or compact material, comparatively rigid, I would say, not exactly rigid in the form of finite element. Yeah, so ballast, subballast and subgrade, these are the three material. These are the five values, and comma C. So this Python syntax you will be notified here, comma, and it takes the value C as 1000 here. So phi is a list and C is just a singular integer which is valued at 1000. So we are taking a C value of 1000. So yeah, here phi is assigned as the friction angle, and phi minus 30 is assigned as the dilation angle. Because if you go into the research article, you will see that there is a formula phi minus 30 for dilation angle, and 0 if phi is less than 30. So we are not assuming 0, although we can create a loop or an if else statement where it can assign based on if phi value is higher than 30 or less than 30, but all the value of phi are higher than 30. So that's up to you if you want to use that. You can also take individual values, but I have created the dilation from here itself, the phi value itself. Then the C value, more column hardening, which is the cohesion. We assign the C value, which is 1000. Then tension cutoff will be C cot phi. So in Python, we use 1 by tan phi. So math dot tan phi and math dot radians. So we are converting our angle of phi into radians. So that's how it calculates the tan phi. So you have to add one more line in your code, including all these lines, to use the math package. So you can just write down import math package, because in ABAQUS math is inherently available, because there are some Python packages which are inherently available in ABAQUS, so you can use them. I guess we'll look into these packages as we go ahead in our future of this tutorial. Then this strain field is taken as 0. Yeah, absolute plastic strain. Yeah, so that's how we assign the tension cutoff and everything else. So this is the part of tutorial which you can see, and mostly you can see it, and which you have seen previously. I'm going to just save it, and now I am going to run. So you can see this is a brand new file. I will again create a brand new. There is a step which is initial, but anyway, I will just create a brand new file, so that yeah, it has been created. And yes, I have been doing some exercise of rounding off, so that's what I have implemented here. So I am rounding off, yeah, here, rounding off of these numbers, because if you don't round them off, you will check that these are like indefinite decimal points, not indefinite, but I guess 8 or 7. So I'm going to run this script now. Now, yeah, so you can see the parts. There are 5 parts, 5 materials, and 5 sketches. Now you can see it is very clear. And we go to property and we see any elastic material like rail. We go to edit and we see that damping, density, and elasticity has been assigned. What we can do is that I have also, although not used any damping for rail and sleepers, but you can remove them or use them based on your own understanding. So SBG mat, which is the plastic material, has all 4 properties: damping, then density, then elasticity, which is very general, and then more column plasticity. Here you can see tension cutoff was 1428, 1000 is the cohesion, plasticity is 30.5. Yeah, so that's what we have taken care in the code, like using tension cutoff as true. So you can make it as false and remove the last line. What I'm going to do is that, because in the journal article I have not used any damping in the elastic material, so I'm going to just cut this line and paste it here and put a tab, yeah, like so. Instead of mats, I'll just copy this mats MC, which is more column, and paste it here, and I'll put damping here. So I'm going to save this so that you can also check out that this elastic materials should not have any damping. I'm just going to close it. I'm going to first, let's create a brand new model. That's the best use of Python you can do, is that you can create your Python script, and from anywhere you can uh, like run the script, so that your model gets generated automatically from the scratch. Yeah, now you can see these materials. Now I'll go to the rail material and see if the damping is there. No, there is only density and elasticity, which is assigned to the rail and sleeper material. So let's check out the sleeper material. Yeah, here is the density and elasticity only. Moving on, we need to in this tutorial, the major part I wanted to cover was to assign the material property to these parts. So I'm just going to go to parts, and yeah, maybe I will start recording the macro from this stage. Now we have our previous macro. We need to go to our file. Yeah, here is the macro. Now you can just open this macro and see what's written inside this. So this is the old macro which we did, but what we can do is that we can overwrite, or we can just create a new macro altogether. So we can create a new macro in working directory and click on continue. From here onward, what we will do is that we'll go to any part. Let's go to last part and go to section assignment directly. Now go to create, and as soon as you do it, you can select all. You can just click on control all, control A, and this name of the set you can choose a set one, that doesn't matter, and click on done. And the section is not created yet, so what we need to do is that we need to create a section, which is section 1, which is BLT section, solid homogeneous. We'll click on continue. Now we have to select a material, which is BLT mat. Now click on OK. There is only one section available, which is BLT section. Now click on OK. So this section has been assigned to the ballast. Now we'll stop recording the macro. We'll go to Notepad++, and yeah, we will reload it because the another macro has been recorded just under the previous macro. Now there's nothing more, just to copy this later part of the macro and paste it down here. Yeah, so again we have to clean this code a bit. I'm going to just shift tab this. Now this viewport lines, we don't require them. Yeah, basically we don't require them. We have P1. Again, this viewport lines can be directly omitted because we are not playing with the viewport now. Yes, this is an important line. Yeah, so you can see this mdb.model homogeneous solid section name ballast material ballast mat just creates a section name by the name of BLT section. So what you can do is that you can create this type of section, and you can just cut this line and paste it here, and you can create another matrix like this, which we are going to copy. So as we are going deeper, this code will become very much redundant, and we can call mat sections and BLT sections like so. So I'm just going to copy this section, and instead of mat I'm going to paste this section. You can shorten the name section to SCT or something, but yeah, that's up to you. Lines will not be visible on your screen. You have to move them to edit them later on, but yeah, it's easy once you get the gist of it. So we have mat section and mats. So instead of sections, we can just put it as section. Now what I can do is, again I will put a for loop for I in range. I'm just going to copy this, so it doesn't matter much. So yeah, for I in range length mats, the length is basically 5 because we have 5 materials, and yeah, that way we can do model 1. This name will change to mat section I, because the I value will be dominating, basically deciding where the material section will be assigned. Then this material will be, again, because we have named this list accordingly, and it is kind of sorted, so we don't need to do a lot of hassling. You can just copy this and paste it here, and I. So yeah, that way we can have different sections. So yeah, we can do that, and this section assignment line will be used, but what I am going to do is that I am going to just remove this P1 line, because we already use P line here for the same reason. So part ballast part, yeah, so although it was not used, so I'm going to comment these lines now. I'm going to save this file, and I'm going to start from a brand new file and see if the sections are created. So you can see before saving this, before deleting this, you can see the section has been created here. So here only one section is visible now. After running the script, we should see 5 sections, but first clear this file So after clearing the slate, you can see there is nothing, only one step. Now we'll run the script again to see if the sections have been created. Yeah, now you can see there are 5 sections like so. Blast section, which has the, we'll just check, blast section has blast material, and any randomly SBG section should have SBG material. Okay, like that we wanted to do. And now let's get back into our Python code where we have p and c is equal to p dot cells, then cells is equal to c dot get sequence mask hashtag number 1, then region is equal to p dot set cells name set 1, then yeah, like so. And again we can remove some files, some lines. Let's uncomment this and clean off this code. Yeah, p equal to this ballast part is again defined here as well as here, so we can remove one line because p is the same value. Now what you can do is that the region which is p dot set cells equal to cell, you can just copy this part c dot sequence and cut it and paste it here so that you don't require this line. So that way you can just remove this line and create a smaller joint of code, smaller chunk of code. And here in this code we have yeah, thickness assignment from section, offset field, yeah, we left that blank, and offset type middle surface. So from middle, if although it's a solid section, so all these lines are pretty much redundant, we don't require them, but we'll keep them because these are default. Offset 0, yeah, these are all default settings. So what basically required here is that region and c is equal to p dot cells. So we can again run our code, and after creating the sections you can again run the code. You can copy this, paste it here, and you can assign tab values here. Now in model 1 we have parts, so we have our part names, and now the part names matrix we haven't created, but now we have to create because this will be required. Now we'll just copy the material matrix, we'll come down a bit and we'll create the part matrix blt.prt. So that's what we are going to do. Yeah, so this is uh, parts, so I'm going to call this matrix as parts, and the length of the part is basically 5, or materials is also 5, so we don't need to go for any change, but here you should change the range or length to parts because all the parts are needed to be assigned with some section. So that's why we are going to run this loop for all the parts. So yeah, in general you should do this kind of changes at various intervals. Here you can have the change of material sections, but yeah, it doesn't matter much because we have all created all the different sections for all different parts. But sometimes what happens is that two parts have the same section, so in that case you might need to change some things. Here in the parts we can just copy this and paste it such that it becomes parts.i, then p dot cell number 1 sequence. Basically this sequence means we are selecting all the part, and from ballast section we can copy this and create the section based on our section. Yeah, like that. Ballast subballast, so this list is sorted, so ballast subballast subgrade, then sleeper, then rail. So as we are using first the plastic part, then the elastic part, in that order. So you can choose your order, but you have to follow all that similar order throughout your Python script. That way you can create a flawless code. Now you can see that we have created the section code as well. Now I'm going to save this file and I'm going to test run this file again. and if it gives us any error, then we'll see what happens. Mostly it should not, because at this stage errors might also start arriving. But yeah, we don't have any errors. Let's see. Now let's we go to property module. If the parts are colored green, then their property has been assigned to them. So we are seeing all the parts one by one, and you can see that all these parts are colored green. And to better understand, you can go to property default, or you can just go to materials. It's much better. Now you can see the color coding of different materials. So sleeper material is kind of gray, so here you can see gray. Ballast material will be kind of green, and then rail material will be kind of white. I don't see the actual colors. Yeah, red I can properly see. Sub ballast, yeah, blue. So yeah, these are different colors. So it means that we have different materials have been assigned, so that everything is working correctly till now. So I guess I will finish this tutorial in this note, and maybe in the next tutorial we'll continue into assembly stage, or maybe some surface or sets creation. So thank you.